Hi, I'm Pat Keeney, an instructional designer with K-12. I'm here with my assistant to work with you on a lab that models how rocks are created and how to calculate density. Conglomerates are made from rock fragments that are cemented together during processes that take place on or beneath the Earth's surface. In this lab, we modeled a conglomerate by using ice as cementing material. As we went through the procedure, we recorded the data in a table. We created a data table with the following columns: rock model, mass in grams, volume in cubic centimeters, and density in grams per cubic centimeter. We prepared for the lab by creating a model of a conglomerate and a large ice cube. For the conglomerate model, we placed small stones and gravel in a small aluminum trough that was roughly rectangular. A small cardboard container could have been used as well. Then we weaved string through the stones and gravel down to the container's bottom. Once the string and stones were in place, we covered the stones with water. For the large ice cube, we filled a similar container with water and string and placed the container in a freezer so that the model would freeze. It took some time, but our advanced preparation resulted in a conglomerate rock model. The models were easily removed from their containers. We quickly measured the mass of each. We attached the strings to a spring scale and observed and recorded the masses. With a metric ruler, we measured the width, length, and height of each. Multiplying the three measurements gave us the volume in cubic centimeters, which we recorded in the data table. We calculated and recorded the density of each block by dividing mass by volume. Next, we investigated the melting rate of each. Did the rock model begin melting slowly, then speed up? Did it melt evenly? Or did it begin quickly, then slow down? Or maybe it was some combination of all of these. What do you think? Before this part of the procedure, we created a data table to record the melting rate, with columns for the time in minutes and mass in grams. To investigate the melting rate, we tied a loop in the conglomerate model's string and then hooked the spring scale to it. We used string and a clamp to hang a spring scale from a countertop and used a bowl to catch the water. We also placed paper towels below the melting model so the falling stones didn't scratch anything. We measured the mass of the conglomerate rock model every 5 minutes until there was too little ice left to measure. Each time, we recorded the mass and time in the data table for the melting rate. The same was done with the rock made of pure ice. You will be provided with the data from this experiment to analyze. This should solidify your understanding of how models are used in science.